All right, question 11. It is necessary to estimate, is it the same thing we just answered? Yeah, to estimate the level of nerve excitability. What parameter is necessary for this purpose? Of course, I just told this was threshold for the force of irritation. So the word itself, threshold, is what you need to take note here.
I just want to know, when do we pick the option D? The
This threshold,
No, no. When do we pick the option D? Like, what would they ask us about?
D, this one. Are you
Yes.
asking about this one?
Yeah.
Okay, this is just not when do we pick, but you need to understand what, because I'm not seeing a question that suggests this as the answer, but you need to understand what the amplitude of action potential is. Now, the amplitude of action potential, quickly to go back, like I told you, is the process itself is on its way to achieve that threshold. It is not there yet. So this is action potential. Let me use this color. This is action potential on its way. So that is amplitude you have here of the action potential. But you can't use this to estimate the excitability level until it has gone to its threshold itself. Then you can say, okay, this is the excitability level. This is the excitability level of this particular nerve. Because it's on its way, you can't say just like okay, you fuel your car, right? Maybe
Mhm.
you fuel your car with full tank, sorry, half tank, and then you say you want to embark on a journey from Kiev to Suni.
Mhm.
Let's say you've never done that and then you want to just estimate and see if it will actually take you to your destination. So what you will do is actually to embark on that journey. You won't stop halfway and say, okay, this fuel can actually take me to Suni. No, you have to complete your journey down to Suni for you to know the actual amount of fuel you will consume. I don't know if that makes sense. So the action potential, the amplitude itself is just on its way. It's just that part on its way going to achieve that what the threshold, the threshold that you have up there. So you can't just stop there and then say, okay, this is the excitability level of this cell. No, you have to achieve that threshold and say, okay, this is the threshold of this depolarization itself. Is that clear enough?
Yeah.
As a result of activating the ionic channels of external membrane of an excitable cell, its resting potential was considerably increased. What channels were activated? Does anyone want to attempt to this?
One second, please.
Membrane of resting potential was considerably increased. A hint, this is hyperpolar. Okay, resting potential, of course, is somewhere here. That's minus 70. But then it was increased. That's like an overshoot coming down here.
Increase, that means
Not
more,
overshoot.
right?
So, sorry, I didn't hear
It's
you.
already minus 70, and if it has increased, that means it says me it's more
That means
minus
is what?
than before, right?
Okay, I know what you're trying to ask. Okay, minus 70, when you increase minus 70, it will give you a more positive number. That means minus 70 increase can give you something like minus 60. That is a different thing. That's for the value itself. But here we're saying that, where's the question? As a result of activating the ionic channels of an external membrane for an external cell, the resting potential was increased. The resting potential itself, which is here, can go down. That's like causing that, where did I even draw that? It should be up there.
Here, increase means it has mean went down more than before, right?
Yeah, that's what it means. So I'm not using the value here, but then we're trying to use the action potential itself, how it has gone down or how it has gone up. So this is the hyperpolarization I was talking about. It has gone down a little from its resting. This is the resting state, and it has gone a little below that. So they're asking now, what causes
But
this?
doesn't this
What ion
mean
item?
decrease?
I think it's activation of potassium if it has been going down.
Okay, yeah, someone just asked, is it not decrease? That's why I mentioned this thing. Sorry, you won't get confused. When you say decrease in normal sense, when you're decreasing minus, okay, okay, it says increase here, right? In the question. When you're increasing minus 70, you have something like minus 60, minus 50, minus 40, isn't it? Because you're increasing it.
Yeah, but here
So,
it's increased.
Yeah,
And
but
if you were saying that hyperpolarization is below negative 70, so isn't that decreasing the resting potential?
okay, let me get that. Minus 70 to
Do you get
minus
my
90
question?
increase. Yeah, I understand. I understand.
I think the
Okay.
negativity has increased,
If negativity has increased, actually, no,
right?
no, it's not negativity increasing. It has to do with the resting potential itself being increased or reduced. Look at this. I'll explain shortly. Now, first thing that's I think Hala, right? Is that your pronunciation
Yes,
of your name?
yes,
Hala. All right, I've
yes,
gotten it. So this is what that's why I started by explaining this. In normal logical reasoning, when you say increased in value of a negative value, you will have a less negative value. That's why you have if you're increasing minus 70, you have minus 60, minus 40, minus 30
exactly.
in that manner. But here we're talking about increased resting potential. Now, this resting potential, okay, let me use the picture I have here. The resting potential itself is here. Where is this picture? This is the resting potential. Forget about the value for now, right? Minus 70, minus 90, forget about that. This is the resting potential, right? And then if it is increased, it means the rest now has been made how will I put this in English now? Okay, take for example, if you normally rest for 4 hours after lectures, and then on this day you play football, you do some activities, you go shopping, you go for some other things actually, and then you come back, you have your class. I'm talking about this kind of evening class, and then you're supposed to rest for 4 hours on a normal day. But because of these activities, it has now increased your timing of sleep. That's your rest hours. Now, this is what it means. Resting potential here going down means it is increased, not the value, but if you are trying to compare a resting potential between here and here, this is relatively small compared to here and here as we have in this picture. I don't know if that makes sense. Here to here.
Yeah,
Here to here is shorter than here to here. So this is more. Does that make sense to you?
your voice is far.
Sorry?
Okay, now it's back. Yeah, so that means it is activation of potassium, right?
Yeah, it's
Okay.
activation of potential. But first to establish why this is increased, the resting potential is just here to here. If you have this, yes, there's resting potential, and then it is just there. Forget about the values, like I said, whether minus 70 or minus 90. But when you have something from here to here, it means the rest is even more than. This one is more than. A is more than B. A is more than B. So the resting potential has been increased, obviously. Yes, I know that this negative value will give you what we call this this minus 70 and minus 90 might bring some confusion, but this is why because this is like on a reverse manner. This is if we're going this way, yes, we'll go by that, but this is trying to reverse. So we use the opposite scenario to explain this terminology. I hope this makes sense too. All right,
Yeah.
so hyperpolarization is what we're expecting there because there's increased rest potential, and with hyperpolarization, the ion obviously has to be what the potassium ion itself. All right, potassium. So the process of energy production were completely blocked in an excitable cell. How will the membrane resting potential change as a result of it? Completely blocked. It is not, excuse me, it is not reduced, it is completely blocked. So you should expect that what it will disappear. Why? Because uh, energy, okay. First of all, the energy production is just like ATP. All of this is biochemistry actually. It's from ATP coming from, okay, it's from ATP coming from the, what's that thing called? From the mitochondria itself. And then so that's what the sodium uses to, I told you they move in and out, right? So definitely there should be an energy that is causing that. So it is the ATP that moves the sodium and potassium movement. That energy in the mitochondria, that's what causes the movement that will give the ions the energy or the ability to move in and out, in and out. So if this energy itself, which is like the basis of where the sodium and potassium is supposed to move, then what you should expect is that what? At the membrane resting potential, sorry, okay, how will it change? The resting membrane potential itself will disappear. Why? Because there's no energy at all. This is not a problem with the ion, saying that, okay, ion is less than expected. Then you say, okay, something like um, it will diminish insignificantly. Maybe that's reduction, I mean, or substantially that's over time it will reduce. No, this is not sodium that is being less or potassium being less. It is from the energy itself that is supposed to produce the movement of sodium and potassium being blocked completely, and that's why we'll have disappearance of this resting membrane potential. All right, a neuromuscular preparation of a frog was processed with poison. After that, the capacity of the muscle for contraction in reply to direct stimulation was preserved, but the one in reply to nerve stimulation was lost. What does the poison block? So neuromuscular is the key word here. And I told you about synapse, neuromuscular junction. So what was actually blocked? Straightforward. What does the poison block? Sorry, is the neuromuscular junction or nervous muscle synapse,
Is it?
obviously.
No. What about the option B?
That's coupling of excitation and contraction in the muscle. No, that's a different thing. That coupling, that excitation and contraction of muscle has nothing to do with nerve and muscle. That's the synapse, the junction itself. It has to do with all those calcium ions, all those what do you call those
Com-
myosin. I'm trying to remember the contraction. There's activation of myosin heads, I mean, that bind to calcium and then they will cause that contraction, that pull, and all of those things. That's a different thing entirely. But for this, it's talking about the junction itself, definitely. And the um it has on the junction, that is in the muscular junction, it has the component that receives the information from the nerve. Remember that first thing I explained to you about the synapse, of course, with the pictures there. It has the tendency to accept. In short, they said poisoning here, but then I told you about that trichinin substance as a poison. Here it just says poison, but later you see a question pointing to that particular poison itself. So this is what it will go there to cover the space where the vesicle is supposed to transport the impulse from the muscle coming, from the nerve coming as the presynaptic, moving into the synaptic space or cleft, and then, like I explained to you, the circuitry, the DN circuitry who is supposed to receive that information has been blocked. So at that point of reception, there's blockage by this poisoning. That's why this neuromuscular synapse itself is where the problem will rely on. Okay, and as an isolated muscle of a frog is rhythmically irritated by electric impulse. And in an experiment, every next impulse has a period of relaxation. I think you have your answer already. So what's the answer of the previous contraction? Relaxation here, not shortening, relaxation.
Is it smooth?
Smooth?
It is
Two.
two-third, partial, incomplete. Yeah, that's what you have there. Relaxation, there's a relax. It relaxes. Just remember the word relaxation, relax. It has gone down to relax. But shortening just means it has reduced over time, and that's all. But relaxation, it goes down, it comes up again, goes down.
Okay, what would be there for the answer to be smooth?
Smooth is when I said that's the question we answered. You remember we answered the question
Yeah,
not long
that's
ago,
why it makes
which
me feel
is
right now.
short period of shortening. Let me write it.
Okay.
Period of shortening.
And the other one is period of relaxation. Okay, I
Yeah,
got it.
that's just the keyword. So a tissue is acted on by electric impulse of cathode direction with amplitude of 70% threshold. What will the changes of membrane potential be as a result of it? So based on what I understand by this, 70 per, take notes. Okay, 70% threshold is not 100%. So if normal threshold is supposed to be like plus 30, but 70%, let's say 70% will be like 22, around 22. However, the keyword or the important thing to note here is that it is not complete. So definitely it is what? Partial. Is it hyperpolarization? No, definitely. 70% is achieved, not negative value. So 70% is achieved, and then action potential is could be an answer, but a more definite answer to give is partial because it is definitely sub threshold. Tissue of tissues acted by electric impulse of cathode direction with amplitude of what will changes of membrane potential be as a result of this. Yeah, that's what it could be. Both action potential or partial depolarization, but it is more um, as the case may be in this crop questions, it is more appropriate to use partial depolarization than the action potential. Action potential is on its way down up to the threshold, so it could be at any point in time. However, that excitability itself, that's where the action potential starts. That's from the resting membrane potential itself. So going upwards up to this threshold is action potential that is being um, occurring. That's more like depolarization itself. But what kind of depolarization? It is partial. Hope you've gotten that.
Actually, wait, can you please explain again how did you link the information and
Okay.
understanding of this question together?
Okay. First of all, the key thing to note here is what the amplitude is 70% of the threshold. So it is not complete. No matter what the threshold is, 70% only was achieved, isn't it? So if 70% is achieved, it means that the threshold has not been achieved or complete. However, like I told you, the um, the options that you might likely go for are either partial or action potential. But action potential itself is just defining depolarization. It's just defining depolarization in general. Meanwhile, for the partial depolarization, it is what we detect because of this 70%. It points out that it is what partial, it is not complete. So that's why I would rather go for the partial depolarization than to go for action potential. However, these two can be an option. So can be options. So if you don't see partial, you can still go for action potential. But if you are if they wanted to go for action potential, they will even mention 70% even. There's no need to mention that. They just tell you the impulse of the cathode direction with amplitude achieved a threshold. So what change of memory potential? What change of memory potential will be the result of it? So it's just action potential, but they wanted you to pinpoint at something. That's why, take for example, someone comes in now to my house and sees me teaching, and they ask me, okay, who am I teaching? I'll tell him I'm teaching some of my students, and that's all. But then specifically, he wants to know students from where? Is it where my teaching hospital presently, or from where? I can now tell him, okay, I'm taking fourth year, third year students of fifth year students of Ukraine for their Krok examination. So I'm being more specific. Now, in this case, 70 is just trying to point at something directly and not just the action potential in general. So the general information is that I'm teaching some students, preparing them for exams. But then, what kind of students or what kind of exams? Krok examinations. So 70% is pointing towards something. Okay, there's a reason why 70 was mentioned. Why not 100? Why 70? So in general, it is action potential that is occurring, which is depolarization. But then If it's 70%, it means it's just partial depolarization that's occurring or sub threshold. Does not reach that threshold. That's why, like I said, I will go for partial than action potential. Two of them can be the answers. It depends on what you see on your option. They can remove this and put something which is completely out of context here. Then, of course, action potential should be your answer. All right, the ionic channels of an excitable cell were blocked, as a result of which resting potential disappeared completely soon after. So, okay, let me zoom this. The ionic channels of excitable were blocked, as a result of which resting potential disappeared completely soon after. So what they're asking is what? The potential, the action potential. Okay, resting potential, sorry, disappeared completely when this ion was blocked. So what channels were blocked? Anyone can attempt this.
1 second, I'm just rereading the question again.
Okay, this is where you have your resting
Is it
potential.
both potassium and sodium?
Okay, that's an idea.
Isn't it sodium?
Sorry,
Isn't it sodium?
also an idea. I would have asked to explain why you're going for potassium and sodium. The person also that mentioned sodium. However, let me just go straight to the point here. So the resting membrane potential disappeared itself. Where is it? Excitable cell were blocked. Okay, as a result of resting potential that were blocked. Now, if the resting potential itself was blocked, that means, okay, in going this way, in trying to achieve, it started from this resting potential, right? And then it is sodium that comes in, you achieve that threshold, and then potassium goes out to reach the resting potential. That's where to stop. On a normal, not to talk about hyperpolarization. On a normal, it's supposed to stop at this resting potential, resting membrane potential. But then, if the resting membrane potential is now, sorry, if this ion, which is potassium that is going out, the channels were blocked, then the resting membrane potential will disappear. And then you won't have this resting membrane potential at all. It means that at this point, sodium has finished its function, isn't it? When it's going up, coming down, it is potassium, the deeds of the potassium, achieving the resting membrane potential.
So
You
here,
understand what?
so you mean here that if we're starting a new resting potential, then okay, I'm confused.
Resting membrane potential is just the start point. You understand? You don't need any ion to achieve that. You don't need any ion at all to achieve that.
But
There's a
didn't
start.
they mean, yeah, but didn't they mean that what stage or what level comes next after the resting potential? Like
No,
this is how I
not
got.
necessarily. Not really. Okay, let me explain again, put in another way. The resting membrane potential is there as a rest state, isn't it? Here it is the rest.
Okay.
Yeah. So you don't need anything to achieve this rest. This is like 0 point or zero mark. You don't need anything to achieve this rest. But however, you need to move out of this rest, which is what sodium coming in.
Mm-hmm.
But however, it has gone up. That's when you need to achieve this rest because it has gone up, isn't it? Then
Yeah.
you need to, it is out of, or it is not around the rest area. So you need to achieve rest because it has gone up. If not, it will continue going up. It will go to plus 30, plus 40, plus 50, and continue going up, which is over depolarization. Well, however, you need to achieve this rest, and that is where potassium comes in to achieve, to take this down back to the rest potential. Do you understand that?
So if we didn't get rest potential, that means because the inactivation of potassium.
Exactly. So the question is asking about the channels that were blocked.
So it is
What
potassium.
channels were blocked? It is the potassium channels, yeah, exactly. That were
Ah,
blocked.
okay, I got it.
So that's what this means. Rest is just there. Sodium doesn't affect rest. It's just moving from the rest state. But then to achieve that rest back, it is potassium that is going out that actually is supposed to achieve that rest itself, but then it has been blocked, so the rest potential itself was not achieved at all. Or do I leave that? Okay. So second to the last question, the ionic channel of an excitable cell were blocked and did not achieve the level of did not achieve the level of resting potential substantially, but the cell lost the capacity of generation of action potential. What channels were blocked? Now, in this case, look at this card here. Of course, ionic channels were blocked again, but then the cell lost the capacity to generate action potential. Where is action potential generated? From the resting point, up, going up.
Sodium and potassium. Could
In this case, it is sodium. Why? Because this is still the same thing I'll keep on drawing. From the rest potential, you have sodium for depolarization, and then you have potassium for repolarization. So this is dip, and then you have rep. So sodium is the one responsible for, that's the action potential occurring actually in this case. Here, action potential, when sodium is going in and then causing depolarization.
Yeah, but don't we
So
need both of them for the generation of action potential?
no, we need sodium. It's sodium that is needed. That's why I put this diagram here. It is only sodium coming in. Potassium will wait first. Okay, okay, I understand what you mean because potassium is going out, right?
Yeah, exactly. Like,
Adam, yeah. But now that's why I told you it is not because potassium is going out that causes the action potential. It is the sodium that is coming in. Potassium is just giving way. So there will be more space for the action potential for the sodium to come in. So it is the sodium itself that is coming in that causes action potential and not potassium leaving. Yes, the action occurring, counter action occurring is potassium leaving, but that is not the cause of action potential. It is just to give room for sodium to come in. And then when sodium is done with its function, then it will come back in again later. That's another phase of this whole cycle. But the main thing is that sodium comes in, potassium leaves. So, however, if in asking your question, in answering your question, sorry, attempting to put in your question, your answer, I mean, in this question, when it is asked, here it is asked what channels were blocked, right? If it is asked what's how do I put? Okay, if you ask the channels that were involved in this procedure itself, then you can go for the sodium, both sodium and potassium channels involved in this procedure. But now something is blocked. When you block this sodium, sorry, when you block this potassium channel,
we
it
will never
doesn't mean
reach
that
resting potential.
no, yeah, that aside, but okay, we're focused on action potential here. So when you block potassium, it doesn't mean, yeah, that means potassium, sorry, cannot go out, but it doesn't mean sodium will not go in. It will just be uncomfortable for sodium inside. Why? Because there's still potassium there. Sodium will still go in, but maybe at a reduced rate and then at a reduced number because there's potassium still there, and there will still be action potential, but not in the normal expected nerve conduction. So blocking potassium has nothing to do with action potential. It's just blocking space, reducing the space for the sodium to come in. That's the only thing there. So blocking the sodium itself is what will actually manifest as the reduced capacity of action potential or depolarization. So the last one here, it is necessary to
Can
get
you please scroll up? I just want to check something. To question 17.
17 itself. Okay.
Yes. Here we picked potassium and sodium, right? Or which
No.
one?
Okay, I didn't take the answer. Here it is potassium.
Okay.
Here it is potassium. And yeah, just to note, I think I saw something. I said we were block, a lot of resting block. Okay, resting potential disappeared here. Here we have okay, did not change resting potential. You see here it is written what? It did not change resting potential. but loss of. So because resting potential, in short, this is more answering your question, Jenna, or your suggestion. The resting potential was not affected. That means sodium itself was not even affected. But then when both resting potential affected, like we answered on question 7, and then there's also loss of capacity of action potential, then you can go for both. I don't know if it's clearer now. It makes sense, right?
Sorry,
Or
when
do I
did you
take
say
it
we
again?
go for both? When we lose the
Okay.
capacity and the generation?
Okay, what I said was you asked, okay, why not both, right? I said,
Yeah.
look at this particular question. Here they said it did not change the level of resting potential. However, here when there was what resting potential disappearing, we said potassium was the cause, right?
Yeah.
That's why we went to question 17. Here
Mhm.
we're told that there's no effect, there's no change on resting potential. That means potassium is intact. However, there's a loss in action potential. That means sodium is affected. If the question was talking about both resting potential affected and the action potential affected, then to be both.
Okay,
That's going
I
to be
get.
both, yeah. So it is necessary to get the increase of the membrane potential, increase of the membranous resting potential, hyperpolarization. This is even the marker here already. In an experiment on isolated excitable cell, what ionic channels will be activated for this purpose? Obviously,
Sodium.
potassium hyperpolarization. Hyper,
Ah, hyperpolarization. Okay.
yeah. So it's potassium here. Okay, I take the answer here. Any question at all?
No, I have to go over it again and see.
All right. So like I always do advise, just take 15, 20 minutes, just go, even if you don't understand, just go through the notes before sleeping this night. Even if you are dizzy, don't keep it till tomorrow. This is how over time you master all of this, and before you know it, you've covered everything. The knowledge, you don't just gather it in one day, you don't gather it at once. It's over time. Every little information you pick, you continue, you pick, you continue, and you move. And that's how you keep on learning. So, well, this is roughly 90 days, and we've achieved a lot today on excitable tissues on under normal physiology. All right, thanks for joining. Have a good day. I'll send the PDF very
Um,
soon.
Thank you so much.